going to study some of the topics related to agronomy, which they have asked in the last few years. So this is 2022 question. So what is geographical information system? Discuss its elements and prospects in agriculture. They're asking elements and prospects. Okay, two things. This is 10 marker. Okay, so you just have 2 pages. So first try to write the definition. So a very simple definition is a geographical information system is a computer system that analyze and display geographically referenced information and is used in input, output, storage, manipulation, retrieval, and analysis of spatial data. This system consists different elements like computer hardware, software, procedure data, and user. Okay. So the major thing which you should remember is the basic. I think you all know that there is a field. Okay. So in that field, uh, we have to do some precise techniques. Okay, like maybe sowing, harvesting, knowing about the pest condition, disease, all these things. So in that we can use the satellite data, okay, like the GIS data, and we can precisely lead to application of all these things based on the required quantity. Okay, based on the necessity, we can apply it. So that is, it is called precision farming, water than precision. Okay. So what are the components is the first part of the question, or the elements or components. Okay. So in components, we have hardware. Okay. So we need an hardware like in computer has an hardware for this also system. And also a GIS software is also needed. Okay. And the data. Okay. Wherein we are going to give spatial and tabular data. Okay, so you understand, I think. See, in case of precision farming, we are mainly dealing with spatial and temporal data. This is like keyword. Okay, because across space we have different data, across space in the field, across time we have different data, and then we are using these two data and analyzing it in software. So these are the major one: hardware, software, and the data. Okay, hardware, software, and the data. And we can also say people and the total procedure which is involved also in some books. Such things are also mentioned. So that is what you have the space to write, just 2, 3 lines. Okay. Then what are its application? Okay, users of GIS. Prospects means that is what is application only. Okay, here you can see. See here, for example, grid sampling guided by GPS. Okay, the soil sampling and the grid sampling can be done by GPS. The next variable rate fertilizer application and can improve efficiency. Means as we are having GS technology, the machine which is running or the machine mounted on the tractor is able to predict what is the like required amount of fertilizer in that area because it has the spatial and temporal data. It will precisely apply that much only. But what happens in field, we apply just 2 bags of urea, that's it in the field. Okay, maybe some regions are having less or more, so based on that. Okay, next variable rate seeding. Okay, based on the soil properties and other things, we can change this seeding also. And crop scouting with technology improves field records. Okay, we are able to analyze and record these data. And also on the yield monitoring. Okay, we have a system to monitor the yield. Okay, and in these are the application, and in the other applications will be like we can forecast the yield also. Like we can forecast the yield. Okay, crop production forecasting, assessment of crop damage and crop progress. Okay, everything is in your control. It's like an what do you say software system which has all the data. Okay, and also crop identification, crop acreage estimation. Then the other which we should remember is with respect to pest. Okay, with respect to pest incidents, all these things. If there is a pest damage, in which area it is damaged, all these things data we can get. Also with respect to disease, similar. Okay, with respect to weed management. Okay, with respect to water, like what is the amount of irrigation based on the color of the plant. Okay, we will be able to know what is the stress level of the plant, what is the um, if any pest or disease attack is there, that we'll be able to know. And also the nutrient content in nutrient deficiencies in the plant can be analyzed by GAS. Because of the sophisticated tools, drones and cameras, we are able to understand all these things. Okay. So crop condition, stress detection, crop yield monitoring can be done, harvesting dates. Based on all this data, we have multiple, like and soil mapping. The what is the status of soil can be understood. Soil moisture estimation, irrigation, post-harvest technology, monitoring of drought. Whatever application you think would fit it, you can write it. But at least you should try to write these important things. After that, you can write other things also, like deficiency, problematic soil, degradation, land cover, all these things. Okay. Next most important question, which next they have asked, is about precision farming. Okay, so this was also asked in 2022. Okay, if you want to read like precision farming, it may take 1 hour or 2 hours to understand, but we'll be discussing it in very brief, touching only key important points. Right? It's different aspects for resource conservation. Okay, they're asking. Then here, like maybe 1/4 of the page, we will discuss basics. What is precision farming? Then another 1.5 page, we will go for the application. Okay, aspects of in case of conservation agriculture. In that case, they're asking application only. So the philosophy behind precision agriculture is that what is needed, we are able to understand. Okay, as needed and where needed, we are going to use the resources. Okay, precision uh, agriculture tools are similar to the geographical information system we are using. It is one of the principle. Okay, in precision agriculture is a very broad term. Okay, in which GIS is a component. Okay, geographical information system is a component. So here also we try to know as needed. Okay, and where needed, we are going to implement these technologies. Okay, so what happens here is that the concept of precision management is also based on the principle of space and time. So based on the space and time, we are going to uh, utilize the inputs. Okay, and localized variation of each farm, like nutrient, water, texture, stage, weed, all these things can be variable. So based on this, we are going to um, uh, like based on all these components are there that will help us to precisely utilize all these components. Okay, it involves site-specific management of nutrients and other components. Okay, so they have. So let us see what are the components. Okay, here we will know like what we need to do at the right time. Okay, how much is the right dose? Okay, or what is the right quantity we need to apply? All these things can be ascertained better in precision farming. See, what are the components of precision agriculture? One is GPS and GIS tools will be helpful. Next is auto steer. Okay, wherein based on the soil and plant and other conditions, the precision management system or the tools which we are using can automatically uh, like what do you say? For example, there is some sowing happening. So based on the auto steer principle, it can show what is the required quantity in that area. Okay, or it has to be uh, uh, put some fertilizers. Then based on the recommendation on that soil on that particular area, that will be done. Okay, and variable rate technology, it is also similar. Like based on the variability present, we are going to apply it. Okay, then artificial intelligence, then the remote sensing. Okay, so data collection and analysis, yield monitor, all these things in a whole component will come under precision farming. Okay, so what are the major objectives to increase the production? Okay, productivity, product quality, to have efficient chemical and chemical use efficiency, to save energy, soil protection, and also major another is environmental advantage, because you are not wasting fertilizers. You know that uh, 80% of 80 to 90% of the nitrogen fertilizers which we use is finally getting into our water bodies. So all these things can be prevented. The environmental advantage is also there. Okay. So these are different components which I discussed: GIS, GPS, computer, sensors, application, remote sensing, all these things. So users of precision agriculture, yield monitoring, they will provide yield by distance and time. Okay, every second or even every few meters, we'll be able to precisely apply the required quantity of fertilizers or any other technologies in the agriculture. Okay, there are n number of things can be done. We're giving few examples. And yield mapping. Okay, we can map the yield before and assessing variability like surveying, okay, modeling, we all these things we can do to assess the variability and managing variability or variable rate application for fertilizers, as I told you. Okay, and also we can use some advanced technologies, okay, like nano urea. Okay, this is also in precision agriculture too. Don't think that this is not precision agriculture too. Okay, and we have expert systems. Okay, these expert systems are there which are like software and systems which will precisely tell what is the um, uh, what is the application we need to do at the right time, at the right dose and right moment, like what is the time we need to go for some pesticides spraying. Okay, all these things will be guided by this expert system. Yeah. And also we have precision management tools, okay, and weed mapping and seed management tools, all these things. And even if you see our fertigation, okay, laser land leveling, all these things also come under precision agriculture too. Means all the technologies which we are doing to bring about and change by which we can precisely use our inputs. Okay. So variable spraying, also insect management and precision water management. Okay, variable rate application, providing drainage. Okay, so all these things can come under this. And the other big advantage is agronomical perspective. Like you can utilize all the inputs in a better way. Technical perspective, environmental perspective, discussed, economic perspective, because economically we are going to use less resources. Okay, like you know about nano urea, so we are using very less resources compared to the normal urea granules. Okay, this is also a precision agriculture tool. And another component which we need to also see, which is not in the question, to extrapolate this question, is this. Okay, the barriers in adoption of precision agriculture tools. Okay, the socio-economic challenges are the principally costs and lack of skills. Okay, and also really, if you want to do all these precision agriculture tools, okay, the major ones, okay, like the GIS system, GPS system, remote sensing. So the farmer has to be rich. Okay, but some things like nano urea, other things, any farmer can do. But all this big investment can be done by the rich farmers because we have small size land holding, cropping system, and land ownership. It is becoming very difficult to adopt. Okay, high cost of obtaining site-specific data. Then we don't have qualified personnel. High initial investment is very high. Okay, and this can be utilized only in places where we have straight land. Okay, easily some places we have undulated land, then we can do precision farming, but it will then we have to spend more money. Okay, then infrastructure and institutional constraint, all these things are also there which you should remember. This not with respect to that question, but extrapolating the question, it may come this year. Next is about we have question about discuss selection criteria for successful bioagents and bioherbicides. State at least two examples of biocontrol of which. So what happens here is that biological control of weeds means controlling the weeds below their economic threshold level using some other organism. Okay, like it may be insects, fishes, pathogens, or some competitive plants, etc. Okay, so what are the characteristics of a successful bioagent? Okay, it should be host specific. Means it should attack only that host. It cannot attack some other related species. It should be host specific. Okay, and bioagent hardiness. The bioagent which you are using should be hardy, not that easily it gets dispersed, or the bioagent which you are using easily dies off. Okay, it should be also hardy. And feeding habit and ease of multiplication should be easily multiplied. Okay, so that it can be distributed in the area, and it can be utilized. So as they are living entities, inoculum plant pathology, mainly fungal. Okay, what we use in our day-to-day uh, bioherbicides are all mostly fungal in origin. Okay, then they are capable of in vitro cultivation in artificial media. Okay, they're commercially formulated and sprayed as herbicide. Okay, so what are the examples? So you should remember the lantana camera example. Okay, that's a weed, and we used by Telemonia scrupulosa. Okay, in India, wherein it was an pest that was used to control lantana. And this you all know by Zygogramma bicolorata for controlling Parthenium hysterophorosis. Okay, then the easy ones you just remember, like Epiblema, okay, for controlling Parthenium, and Neochatina acornea, okay, for controlling water hyacinth, and also like Neochatina brucci for controlling water hyacinth. Okay, so these things are important ones. And also we have Agromyza lantana to control feeds on the seeds of lantana camara seeds. Okay, so some important things we can remember like Zygogramma bicolorata, Parthenium. Okay, then Epiblema sternua. Okay, this is control of Parthenium. Because why I'm telling you, because some 2 3 years back you should have seen in question on directly they asked how do you control Parthenium. Okay, so first is Zygogramma bicolorata and Epiblema sternua. Okay, in Parthenium. This example I don't think you will find in normal books. This is from some specific books. Okay, and also we can use some species like cassia species of weeds. To control the weeds, we can use the cassia species for the control of Parthenium. Okay, this is not given in this one. This one to do. So, what are the bioherbicides which are useful? Okay, so this is very important. Every now and then they ask this question. Example of bioherbicides. Okay, first remember divine. Okay, it is uh, liquid suspension of fungal spore of Phytophthora palmivora. Okay, so the weed controlled is stranglevine. Okay, in case of citrus orchard, and then collagen. Okay, so it is a vegetable powder containing Coleotrichum gliosporides. Sometimes you may find it difficult. Just remember, like Coleotrichum gliosporides, collagen, CC, which is having some relation. Okay, here also bipolaris, bipolaris, sorgicola. This also has a relation. Okay, collagen, Coleotrichum gliosporides. Then it controls joint itch. Okay, mostly in rice field. And then bipolaris sorbicola that controls Johnson grass or Sorghum halippens. Okay. Next is Biolophos. So it is the microbial toxin produced as a fermentation product of Streptomyces hygroscopicus. Okay, so it is non-specific and can be used generally. Okay, so these 3 4 you can remember: Bipolaris, Biolophos, and Collagen.